Hello friends, welcome back to our channel STM Mechatronics. So in this video we will see how to code the STM controller in bare metal programming. So we are going to start the bare metal programming tutorial. Now again I'll scroll you through the system.h file. Sorry, not system, STM32F401 xx.h file from start to end and GPIO.h file from start to end, right? Then we will go from main.c, GPIO.c. Okay, so these will be the basic things that we will be needing in order to configure the GPIO pin as output. Okay, so in STM32F401 xx.h, first thing we have included the stdint.h file for using uint32 underscore t, these kind of variables name, right? Now we have defined volatile macro, we have defined enable, disable, set, reset macros, we have defined the memory addresses for different peripherals and the buses. Okay, so we have defined the base addresses for bus and the peripheral, different peripherals, and the RCC peripheral. After that, what we have done is we have created a structure for GPIO and for RCC. Now inside the structure we have mapped the registers with offset. Okay, so for GPIO we have mode register, output type register, output speed register, pull up pull down register, input output direction, bit set reset, lock registers, and alternate functionality register. In RCC we have different registers. It is mapped according to the offset. So control register, PLL configuration, okay. Then APB1 reset, AHB1 reset, AHB2 reset, AHB1 in ENR, AHB2 in ENR, enable registers, right? APB1 enable. And then we have few reserved, right? Now few reserved bits. So these are mapped according to the register map of RCC. After that, we have created the structure pointers for different peripherals, GPIO and RCC. Then we have included GPIO.h at the end of the file. Okay. Now going into GPIO.h. So we have included this STM32F401 xx.h because we want to use these macros also, right? These macros, pointers, basically structure pointers. Now to enable the clock peripheral, right, for different GPIOs, we have created these macros. Okay, now we have simply created the macro function names, okay, to enable the peripheral clock. To disable the peripheral clock, we have created these macros. Okay, now for GPIOs port pins, we have created these macros. Now for modes, GPIO pin modes, we have created these macros. Okay, then the output types, whether push pull or open drain. Then the speed, for speed we have created macros. For pull up pull down we have created these macros, right? Again we have created this one structure. We will see why we have used. So basically which pin we will be needing to be configured, what will be the pin mode, okay, what will be the speed, whether it will need the pull up pull down, its output type, input output, okay, sorry, not output type means it will be either push pull or open drain, and the alternate functionality mode. Okay, so for this we have created this structure, GPIO pin configuration structure. Okay, now we have created another structure. So in this structure what we are going to do is we have created one structure pointer, right, GPIO-X of type GPIO regdef T. So using this pointer we can use the GPIO regdef T structure variables, right, and we can assign the values. Now GPIO pin config. Now the values, variable values, or here the structure variables we can use directly using this. Okay, so we have created the structure variable and we have included that into another structure. Okay, and these are the like GPIO init, GPIO clock control, enable, disable. So these are 4 different functions that we have included in the GPIO.h file. Okay, now coming to GPIO.c file. First function we have is GPIO init, right? Now we know that like we have to enable the clock of the respective GPIO, right? So we have taken one temporary variable, GPIO clock control. We have created this function, right? For GPIO init, like we are passing the GPIO handle structure pointer. Okay. Now in GPIO handle structure pointer, you can see like we have 2 members. One is the pconfig tick structure and one is pointer for regdef t, right? So we have passed that in the GPIO init. Now using this pointer, what we are going to do is we are going to pass the GPIO x, which is pointer to regdef, right? Which is defined in STM32F401 xx.h, right? And we want to enable that peripheral, GPIO peripheral. Okay, so that we have done. Now we are going to check, like we have this pointer, we are checking whether it is GPIO A or GPIO B or GPIO C, which GPIO it is, right? And if it is enable, now this enable or disable. If it is enable, then enable the clock peripheral. If disable, then disable the clock peripheral. I have not written the code that you can do it, right? Simply like we can copy paste this code, right? We can copy this, and instead of clock enable, we can use the clock disable function, right? Now, if you see, like this will point to certain memory. Now again, GPIO is again a pointer, right? This is again a pointer of type regdef t, right? So here you can see that we are passing one pointer and we are checking whether the value matches with the macro that we have created, right? If it matches, like if the peripheral that, like if you want to enable the clock for GPIO A, if it is passed and if it matches with GPIO A, then we will enable clock for GPIO A. Else we will go and check which peripheral has been passed, or which GPIO clock peripheral has been passed, and then we will enable clock for that, right? So this is simple, like GPIO peripheral clock control, right? And we have already written this function, GPIO clock enable. Over here you can see that like we are enabling, each GPIO is connected to RCC AHB1 bus, right? Each GPIO is connected to AHB1 bus, right? So in RCC register, we will have to configure AHB1 ENR enable register. Then we have to give the peripheral clock GPIO peripheral name, right? Whether whether it be the GPIO A, GPIO B, GPIO C, or that, right? So it is simple. Once we have enabled the clock, so this is very important. Before configuring any register of GPIO peripheral, we have to enable the clock for that peripheral. Okay. So in bare metal, this is one condition. So before writing to or before configuring any register of that peripheral, we have to enable the clock of that peripheral. So if you are writing for the SPI peripheral register, the clock must be enabled for that SPI peripheral. Likewise, okay. So the first step that we are doing is we are enabling the clock for GPIO A. Okay. Then we have to set the mode. Now we have to set like it as output mode. Then we are going to set like the output type, whether push pull or open drain. Then we are going to set the pull up or pull down and the speed. Okay. So here you can see that like in GPIO handle, right? GPIO handle, we have pconfig T and GPIO pin mode, right? We have pconfig T, right? Pconfig T structure, and it is a direct variable, so we can use it using a dot operator. Okay, so GPIO p handle, pconfig, and pin mode. Okay, this is user for user configuration, right? So here we will get the configuration from user, and then we will pass it to configure it in the register definition, right? So the pin mode that is set by the user we will get, and we will write it into temp register. Now in GPIO X mode register we will have to write that value. Okay, same goes for output type, same goes for PU, pull up pull down, and same goes for output speed. Okay, so now we'll see the mode register, right? In our configuration, right, you can see that we have taken the value from the user configuration structure, right? First thing that we are clearing, then we are taking the value from the user and storing it into the temporary variable. Okay, we are left shifting, multiplying it by 2. So multiplying it by 2 will be left shifting it by 2 values, right? One value. So what we are doing is, so what will be the value, whatever the value is, right? We are left shifting it. So if you see, like 2 bits are reserved for mode register. So mode register 0, mode register 1, mode register 2, not mode register 2, but these will be the like port X configuration bits. So port GPIO port A, right? GPIO port A and GPIO port A pin 0, right? GPIO port A pin 0, 2 bits will be used. GPIO port A pin 1, 2 bits will be used. GPIO port A pin 2, these 2 bits will be used likewise. So if we configure these bits as 0, 0, then it will be in the input state. If we configure these bits as 0, 1, right? So 0, 1, it will be in the output, general purpose output mode. So if you see, right, what we are doing is, we are, whatever the pin number, right, multiplied by 2, and we are left shifting that value which is stored in the pin configuration mode. Okay, so likewise we are configuring the value for the GPIO pin mode. Okay, so what we are going to see again, if this becomes a bit complex explanation, I'll go simply over here. So in GPIO.h, right, we have created a structure of GPIO handle, right? Now we have created one variable, GPIO handle. Actually we have created two variables over here. One is pointer, right, and one is direct variable, a simple variable. One is a pointer variable and one is a simple variable. So GPIO handle A, GPIO A underscore 1, this is the name of the GPIO handle for GPIO A. Okay, now we have in the GPIO handle, right, in the GPIO handle we have one pointer variable and we have one structure variable. So what we want to do is GPIO, we can directly access those, right? GPIO A dot X, now we are assigning the pointer value, GPIO A base address to it, to the pointer variable, right? Now in the second structure variable, like GPIO A, GPIO pin config, this is the structure variable, right? In the structure variable we want to configure these values. So the pin number, it will be GPIO pin 1, pin mode GPIO output, we want to use the pull up, output type is push pull, and pin speed is output low. Okay, and then we are calling GPIO init and we are passing the address of this GPIO handle T. Okay, so if you go inside this, see we want the address. This is a pointer variable, so we are passing the base address of the structure, right? Then we are configuring this. Now we want to configure it in output mode, right? We want to configure it in output mode. So 1 is this value. Now this value will go into, it will be passed as 1, right? Now we know the pin number. We want pin 1, GPIO pin 1, right? So we have passed 1, first pin mode. 1 will be stored over here, right? 0x01. We want GPIO pin 1, right? So pin 1 value is 1 multiplied by 2, right? So it becomes 2. This value becomes 2. Now 1 left shifted by 2, right? So it will become, so first the temp was like, the value of temp variable was 0001. I'm only taking the list 4 bits, right? After that we are left shifting it by 2, right? So 0001, so it will be left shifted by 2 over here, right? Now in the mode register we know that if you want to configure the port pin as output, we have to write 0x01 into the mode register of that respective bit, right? So to configure port GPIO pin 1 as output, we have to write 0, 1 over here, right? So what we have done is, first we have taken 1, then we have shifted it by 2, right? Because each pin takes 2 bits for configuration. So that's why we have multiplied it by 2, okay? This is simple. Now for output type, again for output type, what we have to do is, we'll go inside the output type register, right? So for output type we don't have to left shift it by 2, left shift it by the GPIO port pin into 2. So simply like we are going to use the 15 bits because we have total 15 pins for the GPIO, right? So we can directly use like GPIO pin number, right? So for output type, what we are doing is, we are taking the value that which is configured by the user into temp variable, and then we are ORing it with output type register, and we are shifting it by the GPIO pin number, okay? So for now, like we want to configure GPIO pin 1, right, of GPIO port A, then we have taken the value, right? We want to create it as output push pull, so that's why we have kept it as 0, and 0 left shifted by 1, it will remain as 0, okay? So if you see over here main.c, right, we want output type, right, push pull. For push pull we have written it as 0, okay? Now pull up pull down. So for pull up pull down, we again have 2 bits, right? So for pull up and pull down, we have 2 bits for each GPIO port pin, okay? And like when we want to use the pull up, or when we want to configure the pull up for the GPIO port pin, we have to write 0x01 into that respective 2 bits of the port pin, right? So again what we have done is, we have used this same logic which we have used for the mode register, right? Only the difference is pin PUPDR control, right? Pull up pull down. Now we have used the pull up, right? So we want to write 0x01 for 2 bits which are reserved for GPIO pin 1, right? So we have to write 1. That's why pull up is configured as 1. This micro has been written as 1, right? So 1, it will be stored in temp. Then temp is left shifted by pin number multiplied by 2. So the pin number is 1. 1 multiplied by 2 is 2. So again 1 is left shifted by 2. So this value again comes to the PUBDR. Okay, pull down register, and we have kept this output as low. So this way we are configuring everything. Okay, now if you see, we have configured the GPIO port pin. Okay, till now we have configured the GPIO port pin. We have not written any value to the port pin, right? To write the port pin value, output direction register, right? We have to use this value, output direction register. Not output direction, output data register. Okay, so writing to, like, we want to use this bit, like port GPIO pin 1, right? So we will have to write to bit 1 of output data register, right? ODR register. So writing these bits can be read and written by software, right? For atomic bit set reset operation. So when it is written 1 as 1, the output will be 1, and when it is written as 0, the output will be 0 on the GPIO pin 1. Okay, so if you go over here, output data register, first we are writing 1. It means what we are doing is GPIO pin 1 is set. It's set. Okay, now here what we are doing is GPIO pin underscore 1 is reset. Okay, now we are ORing, right? We are taking 1, we are left shifting it by the GPIO port pin number, right, which is 1. So 1 left shifted by 1, it becomes, so 0x0001, right? Not 0x, but it becomes in binary, it becomes 0010, right? Now we have given millisecond delay, and then we have cleared that value for the port pin. Okay, so this is very simple code, very simple to understand. Okay, now we will build this with the latest code. We'll load the code. You can see the latest timing. Okay, so you can see the port pin is toggling. Now if I want to change and make it to pin port 2 or pin port 3, right, I can do that. What I'll have to do is I'll have to change it over here also. Okay, build the code. Now what I'll have to do is I'll simply have to reconnect over here, cut the connection, right? Now GPIO port GPIO A PA3 is toggling. Okay, so this is the bare metal programming tutorial. If you have any doubts regarding this video or regarding the explanation, you can post it to me or send the query to me, right? So this is very simple thing. In the next lecture, what we will see, we will configure the GPIO as input pin, right? We'll try to understand how the configuration works, right? Again, this code will be same. Okay, one thing that I have forgot to mention, like how to create the new project for bare metal programming. So click on file, click on new, click on STM32 project. Select the controller. In my case, it is F401 CCU6. Okay. Now I have selected the controller. Give the project name. I'll give it as bare metal underscore 401 cc, right? And I'll give it as 1. Now in the options, like targeted language C, targeted binary executable, and here, like you can see the targeted project type, we want it as we want it as empty. Okay, so click on finish. So here you will see that we don't have any STM32Cube right? The window that we get for the pin configuration. Here it is not there. Okay. So we are like directly configuring our own, and we are writing the configuration to the registers of GPIO or any peripheral, right? And we will be seeing whether it works perfectly fine or not, right? So this way we are configuring, we are doing that. Again, if you have any queries, right? So here I have uploaded this bare metal GPIO. So from here you can download it, okay? Then create your project just like that, just like I have shown it to you. Add these files in the project folder, okay, and run it. So that will be very simple. Okay. So thanks for watching this video. If you have any query, okay, any query regarding the explanation, any suggestion regarding the videos, you post it in the comment section. I will reply to those, okay? And if you like the explanation, please give it a like, share with your friends, and thanks for watching the video. I'll see you in the next video.